Hi students, welcome to Get It Free. Hope you are doing good. This is Raghuvamshi. I have 5-year plus experience as a gate trainer. This is the only channel which provides the gate classes at free of cost. Though we are providing the gate classes at free of cost, we do not compromise on quality as we teach every subject from basic level with practical examples. When I was coaching in some institutions, I observed one thing. The lecturer is not given sufficient number of hours to complete the subjects. So there may be chances to skip some concepts, and we cannot solve sufficient numericals due to time constraint. But don't worry, this will be taken care here. And in this channel, every subject will be dealt in detail as per GATE syllabus, and sufficient numericals will be solved in class. All the lecturers in this channel are highly experienced in their respective subjects, and all the subject materials, question booklets will be provided in our Telegram channel, and the link will be given in description. Now, before starting the class, I want to share my experience with you. When I was a student, I faced so many difficulties to afford the GATE coaching as it was expensive. But I don't want any student to face these problems. So the main intention to start this channel is to provide quality GATE coaching for free as a service. Right. Next, we are going to start the subject. Before starting the subject, please support us to make this initiative a success. Please like, share, comment, and don't forget to subscribe our channel. Press the bell icon to get latest updates. Right. Now, myself, Raghuvamshi, I am here to teach the total thermal part and heat transfer. The total thermal part divided into 3 topics. One is thermodynamic basics, basic concepts, and second one, power plant and IC engine, and third one, refrigeration and air conditioning. First, we will start the thermodynamic basic concept. Right. Now let us see the weightage in GATE marks. In thermodynamic basic and power plant IC engine, the average marks in GATE exam are 8 to 10 marks. In refrigeration and air condition, we can expect 2 to 4 marks. Now, what are the reference textbooks for thermodynamics? For thermodynamics, the reference textbook I prefer for concepts, Sengel and Bowles. Now, in this textbook, he explained the concept in practical manner. For numericals, refer PK Nog textbook. Okay. And my sincere request, please maintain running notes, because it will help you in quick revision. Anyway, we provide material in our Telegram channel, right? Now, before entering into this subject, thermodynamics. What is meant by thermodynamics? As we know that thermo means heat and dynamics means study of motion, or simply we can say power. Okay, right. First of all, we have to ask ourselves three questions before starting this subject. Now, what are the three questions? Why we are studying this subject? What is the use of this subject? And where we are going to apply this subject knowledge? Let us see in practical manner. Okay. First, we learn the basic concepts from the thermodynamics. Now, in industries, example in power plants, or maybe in developing IC engine industries, motor industries, there the scientists will develop some machines. Okay. Those machines must and should be in efficient manner, is it? Now, as an engineers, our work is we have to analyze the machines, we have to learn, analyze, and our work, our duty is to improve the efficiency. As we know, the most of power plants, thermal power plant. What is the efficiency? The efficiency of thermal power plant is only 28 to 30%. Do you know that one? Means almost 70%, almost 70% is losses. See here, how much energy we are wasting, how much energy becomes useless. Okay, right. Now, as an engineer, we have to improve this efficiency. That is the main role of an engineer. To improve the efficiency, we have to learn the basic concepts very clearly, right? Now, let us discuss the chapters in thermodynamics. First, basic concepts. Next, zeroth law of thermodynamics. Next, work and heat transfer. First law of thermodynamics. After that, second law of thermodynamics. Next, entropy chapter. The entropy chapter is very, very, very important, especially for gate point of view. Okay. Next, availability and irreversibilities. Next, properties of pure substances. And last, thermodynamic property relations. Thermodynamic property relations. Okay. These are the chapters in thermodynamics basics. Right. Hope you note these chapters. Right. Now let us see the definition. Now, definition of thermodynamics. The thermodynamics, it is the science of energy transfer. The science of energy transfer. It may be heat or work transfer or both including, that is heat and work transfer. Okay, the science of energy transfer with the effects of properties on system. Okay, right. We learned what is the definition of thermodynamics, but what is the aim? This is very, very important. Aim. The aim of our thermodynamics. The main aim of thermodynamics is to convert the disorganized form of energy into organized form of energy in an efficient manner. So whatever the mechanism, whatever the machine we have developed, that should be in efficient manner. If there is no efficiency, then what is the use of machines? Okay, right. Now what is meant by disorganized form of energy? What is meant by disorganized form of energy? Here I am saying the disorganized form of energy as a heat and organized form of energy as a work. Why I called heat is a disorganized and work as a organized form of energy. Now let me explain in practical manner. Okay, Let us see why I called heat is a disorganized form of energy. Okay, let us take a wood and supply some heat. What happened? Due to internal energy of this wood will give some heat energy. Now let us say, what is the direction of heat transfer from the wood? The heat transfer in any direction. Hope you understood. The heat transfer by burning the wood in any direction. It move in randomness way, in all direction. Okay. Now whatever the heat developed by the wood, that heat cannot be converted as a work. We cannot convert this heat, directly this heat into work. Okay. This is very, very difficult. Why? That is the reason the heat is a disorganized. It is a disorganized form of energy. We cannot convert that heat into directly work. Now let us see how we can convert the heat into organized, that is work. How and why I called work as a organized form of energy. For example, let us consider an IC engine. All of you know that IC engine parts. This is cylinder, piston, connecting rod, crankshaft, and the output is mechanical work. Right. We know that after combustion process, there will be a lots of heat generation. Now due to that heat generation, the pressure forces, these are the pressure forces exerted on the piston head due to the combustion, due to the heat. I can say the heat pressure forces developed or exerted some pressure on the piston head. Okay. Now the piston will move in downward direction. That linear motion of piston is converted into rotational, that is mechanical work output. See here also same heat, and in this case also same heat, but in second case we are converting the heat is a disorganized form of energy. We are converting the heat disorganized form of energy by using some constraints into organized form of energy, that is mechanical work. And why I called work as a organized? Let me explain. See here, the disorganized form of energy heat converted into organized form of energy work by using some constraints. There must and should be some constraints to convert the heat into mechanical work. Okay, right. Why I called work is a organized form of energy. I will discuss in practical manner. All of you know the bike. Yes. We know that the bike runs with the help of an IC engine. Yes. In IC engine there will be combustion, power stroke, from that mechanical work. From that we can ride a bike. See here. You can ride the bike whatever the speed you want. Yes or no? 60, 70, 80, 90. Yes. You can take left hand, you can take right side, right. You can stop wherever you want. What it means? It says that the work output from the IC engine, the mechanical work is in our control. That is, we can ride whatever the speed we want. We can take left turn, right turn. We can stop wherever we want. That is, the work is in our control, we can use that in a systematic way. Understood? That's why I called work is a organized form of energy. This is the beauty of thermodynamics. Understood? Hope you understood. Next, let us discuss the basic concepts of thermodynamics. And we can see this example in steam power plant also. First, by using some combustion chamber, by using some fuel products, for example coal. From that, the heat is transferred to the boiler. We know that in boiler it stored some water. That water is converted into steam with the help of heat supplied by the combustion chamber. Now, the steam having high pressure and high temperature. Now the steam entered into a nozzle. Now what is meant by nozzle? It is a varying cross section of area or simply converging cross section of area. What is the working principle of nozzle? It converts the high pressure energy into high kinetic energy. Now with the help of high kinetic energy, the turbine blades or simply the turbine rotates. With the help of turbine, we can get some mechanical work output that is subsequently converted into electricity. Okay. Now if the working fluid is gas, that is known as gas power plant. Here the working fluid is water. So this is steam power plant. Let us start the basic concepts. The basic concepts of thermodynamics. First heading, thermodynamic system. Now we will see what is meant by thermodynamic system. It is a region in space upon which our study is concentrated. Okay, what is meant by thermodynamic system? It is a region in space upon which our study is concentrated. For example, now I want to study about this room. Okay, I want to study about this room. Now my focus is only on this room. Now how many objects in this room? What type of board it is? Now what type of camera it is? Now how many chairs are there? Now this is my study in this system. So for example, I want to study the total building. Now, how many rooms are there? How many windows are there? How many gates are there? Now, my system is the total building. Next, surroundings. Now, what is meant by surrounding? Everything external to the system up to where its effects are felt is known as surroundings. Now let us see this in practical manner. For example, let us consider this is a room. Okay. In this room, we have a IC engine. Now we are doing some testings on the IC engine. Okay. Let us consider the IC engine as a system. Now listen carefully. Now what is our system? The IC engine is a system. Now our study, okay, we are focused only on the IC engine. What are the properties are changing? How the IC engine is working? That is our study. Now we have considered the IC engine as a system. Now we know that there is a combustion process. Due to that combustion, there will be some heat generation. That heat, some of the heat will transfer from system to the outside of the room, from IC engine to the outside of the room. Now let us consider the heat transfer up to the walls of the room. If you stand beyond the room, for example, if you stand beyond the room, you cannot feel any temperature of the IC engine. You cannot feel any heat travel from IC engine to outside of the room. It is not possible. Okay. We know that the heat transfer from higher temperature to lower temperature up to thermal equilibrium. Yes. Now what is meant by surroundings? Everything external to the system up to where its effects are felt. Now what are the effects here? We have to consider the surroundings up to where the heat transfer. Okay. Now this is surroundings. Okay. Please don't consider outside the room as a surroundings. Understood? There is a misconception of surroundings. Don't consider the outside part of a room as a surroundings. You have to consider up to where the system effects are felt. That is surroundings. Right. Next. Boundary. Now what is meant by boundary? Simply, it is a separation layer. The separation layer between system and surroundings. The separation layer between system and surroundings. Okay, this is system, and this is boundary, and external to the system are surroundings up to where its effects are felt. Now last, universe. Next, make a side heading, universe. Now what is meant by universe? Combined system and surroundings is known as universe. See here, the system and surroundings together called universe. Okay. Next, let us see one example on surroundings, system and boundary. Now let us take an example of boiler. Okay. This is a boiler. Now inside the boiler there is a water. Now our system is boiler. Now what is this layer? Boundary. Okay, the boundary may be fixed, real or imaginary. That we will discuss later. Now we know that by supplying heat from surroundings to the system. Now what is our system here? Boiler. Now by supplying heat from surrounding to the system, that is boiler, the water absorb heat and converts into steam. That steam enters into nozzle and subsequently it converts into kinetic energy, and from that turbine mechanical work output will be produced. So here that simply I am explaining what is meant by system and surroundings and boundary. This is simple an example of system, surroundings and boundary. Next side heading, classification of thermodynamic system. Next, make a side heading, classification of thermodynamic system. This is very important in thermodynamic basics. Now first side heading, closed system or non-flow system. Closed system or non-flow system. It is a thermodynamic system. It is a thermodynamic system in which only the energy interaction takes place between system and surroundings. There is only energy interaction between system and surroundings, but not mass. We will see in simple diagram. Let us say this is system and this is surroundings. Okay, what I said, the closed system or non-flow system means there is only energy interaction between system and surroundings. It may be from system to surroundings or from surroundings to systems. Here energy is nothing but heat. Okay, now heat is not equal to 0. Okay, now mass transfer in a closed system, the mass transfer does not take place between system and surroundings through boundary. Therefore, there is no mass interaction. Can I say mass interaction is equal to 0? Now, this type of system is known as closed system or non-flow system. Now, what are the examples? Closed container when heated and piston cylinder arrangement. Let's see the closed container when heated. This is a closed container. Supply heat to the closed container. In this closed container, air or any gas is present. Now what happened? The gas present in the closed container will absorb some heat. Means there is a interaction between, there is a energy interaction between surroundings to system. Now what is our system here? The gas or air is system, and from surroundings to the system there is energy transfer, that is heat transfer. See, as this is a closed container, there is no mass transfer. This type of thermodynamic system is known as non-flow system or closed system. Next heading, open system. Or flow system. Alright, now in open system or flow system, both or it is a thermodynamic system in which both energy and mass interaction takes place between system and surroundings. Okay. Now it is a type of thermodynamic system in which both energy and mass interaction will be take place. This is our system. Boundary, surroundings. Okay, here there is a energy interaction, means it is not equal to 0, and mass interaction between system and surroundings, and mass transfer is also not equal to 0. This type of system is known as flow system or open system. What are the examples? Compressor, turbine, pumps, boiler, etc. These are the examples of open system. What is meant by control volume? Simply just note down, control volume is the volume of open system is known as control volume. Now we will see one practical example of open system. Let us take an example of open system, turbine. See here. Okay, we know that turbine is a device which converts, which produces mechanical work output. Now, what is the system? Our system is turbine. Surroundings. From surroundings, the mass and energy. What type of energy? Heat energy. Here we can say the type of energy is enthalpy. The mass and energy entering into the system from surroundings and leaving from system to surroundings. Both mass and energy enters into the system from surroundings and leaving from system to surrounding. Okay, let us say this is M and H2. If you see, we know that from boiler the water converts into steam. The steam having high energy, it enters into the turbine, which helps in rotation of turbine. With the help of rotational energy, we will get some mechanical work output. For example, in approximate value, the enthalpy of steam before entering into the turbine is 3200 kilojoule per kg. Now, After leaving the turbine, the enthalpy is reduced to 1200 kilojoule per kg. Now, what is the reason? What happened? Now, what is the reason of enthalpy drop? The enthalpy drop represents the mechanical work output, that is H1 minus H2 is equal to how much? 2000 kilojoule per kg of work done by the turbine. Hope you understood the example of open system. Next we will discuss isolated system. Next heading, isolated system. Third one, isolated no, it is a thermodynamic system in which neither mass nor energy interaction takes place between system and surroundings. Okay, there is no mass interaction, there is no energy interaction. This is system, surroundings. Can I represent? Mass interaction is equal to 0 and energy interaction, that is heat, is equal to 0. Okay, this type of system given name as isolated system. Now, what are the examples? Example, universe or a perfectly I am saying perfectly insulated tea flask. 100% perfectly insulated tea flask. And why I said universe is a isolated system? Because system, surroundings, and this is universe. Now, whatever the energy interaction, mass interaction, only between system and surroundings, but not beyond the universe. Okay, that's why the combined system plus surroundings, we can call it as a isolated system. Simply that is universe. Okay, the next topic, and make a heading of properties. The properties are very, very important in thermodynamic concepts. Make a heading, thermodynamic properties. Before this, you have to know what is the meaning of characteristics. See, what is meant by characteristic? I will explain with some example. Let us consider two containers with water okay. Now both containers containing water. Okay. In this first case, the water temperature is room temperature. For example, 25 degrees centigrade. In second case, the water temperature is 60 degrees centigrade at atmospheric pressure. Now listen carefully. Now how can I specify, how can I show the condition of water to you people? Okay, while I am standing in this room, I can say this water is, the second case water is warmer than the first case. But how can I say, how can I show this condition to you people? I need some parameters. I need some characteristics. Is it or not? Now, what are the characteristics? How can I represent the second, in second container, the water is warmer than the first container? I need some characteristics. Now, what is meant by characteristic? In this case, the temperature is a characteristic. Okay. To distinguish or to differentiate any two objects, any two persons, any two materials, we need some characteristics. For example, this is iron and this is wood. Or here the characteristic is different materials. For example, if you take both iron, this is mass M1 is 1 kg, here mass is 2 kg. Now both are iron material, but how to specify the condition? With some characteristics. Okay. Now this is the first case, mass is 1 kg and second one iron is 2 kg. Now here the characteristic is mass. Understood? But what is meant by property? What is meant by property? Right. Any measurable characteristic is known as property. It means, can you measure the smell? Can you measure the sensation or the sense when I touch any object? Okay, there is no measurement of smell and sense. These all are characteristics. The characteristics are nothing but it may be temperature, mass, volume, pressure, density, smell, sense. These all are characteristics to specify a condition. But any measurable characteristic is known as a property. Okay. Now make a side heading, property. Now what is meant by property? Properties to specify any thermodynamic system, we need some characteristics such as pressure, temperature, volume, etc. I will discuss later. For example, let us take a closed container. Let us take a closed container which contains air or gas. Now, how can I specify the condition of this system? By knowing its properties. What are the properties here? For example, pressure P1 is 1 bar and temperature is 25 degrees centigrade. Mass 1 kg. Volume 1 meter cube. Now, this is the condition of the system. After supplying some heat, the condition of system may change. Okay. Now, with the help of properties, we can specify the condition of a system. That is the importance of properties. Next, okay, to specify any thermodynamic system, we need some characteristics. Those are measurable characteristics as pressure, temperature, volume, etc. are known as properties, thermodynamic properties. Now, the properties are classified into intensive properties and extensive properties. The properties are classified into intensive properties and extensive properties. Now, first note down the definition of intensive properties and extensive properties. Now, what is meant by intensive property? The intensive property, the properties which independent on mass or size of the system. Okay, the properties which are independent on mass or size of the system. Now, what is meant by extensive properties? And these properties are dependent on mass or size of the system. Okay. Now, let us discuss in a practical manner what is meant by intensive properties and what is meant by extensive property. Let us consider a room. Let us consider a room. Now, how to specify the condition of the room? With the help of properties. Now, in this room, we have some air. Now, what is the condition? With the help of properties, we can specify the condition of the system, right? Now, pressure, atmospheric pressure, let us consider it as a 1 bar. Temperature, now what is the room temperature? Approximately 25 degrees centigrade. Density, let us consider 1 meter cube, 1 kg per meter cube, and it has some mass, for example 1 kg, volume, for example 1 meter cube. Now listen carefully. Consider the same room. Let us divide the room imaginarily. Okay, I am not dividing completely. Just assume that we have divided that room into two parts. Now let us see the which properties are changed. Okay, I have divided this room imaginarily, just imaginarily. Now you have to say what are the properties are changed. Okay, see here. This is okay, right side, and this is left side of room. Just imaginarily we divided into two parts. Okay, not really. Now what is the pressure on right side? Now just divided this room. Now what is the pressure on right side and left side? Is it same? There is no compression, there is no expansion of gas. So the pressure on both sides are same. 1 bar, and here also 1 bar. Next, what is the temperature? There is no heat absorption, there is no heat liberation to the outside. So the temperature is also same. Next, what about density? Is there any change in density? First, what is meant by density? Density means mass per unit volume, kg per meter cube. Okay. Is there any change in density on right side and left side? See, there is no compression of gases, there is no expansion of gases. Then the density is also same, means on the left side of room in 1 meter cube volume, okay, or okay, 1 meter cube volume, the mass present is 1 kg. There is no compression. Yes, on the right side, okay, on the left side of the room also it will be same. Okay, now 1 meter cube per kg and 1 meter cube, sorry, 1 kg per meter cube. There is no change in density. Next, let us see what about the mass. Definitely there is a change in mass. Yes or no? We have divided the room imaginarily. Then definitely this is the half of the total M. Okay, let us take this as capital M. Okay, simply I am writing it is just half. On the left side, same. Let us consider it is divided exactly at middle. Now what about volume? Yes, the volume also changed, half. Now listen carefully. Now let us see the conclusion of this example. Okay, the same room I have divided imaginarily, just partitioned imaginarily, not completely. Just by dividing imaginarily the room, some properties are changed, some properties are not changed. Now what is meant by intensive property? Intensive property means independent of mass or size of the system. If the size of system changed, the properties should not be changed. Those properties are known as intensive properties. Now you have to say what are the intensive properties here? The pressure, temperature and density are intensive properties. Now what is meant by extensive properties? These properties depend on the mass or size of the system. Here we have changed the size of system. We have divided the mass. Yes or no? Now what are the properties are changed? Mass and volume. Okay. Now the mass and volume are extensive properties. Okay. Hope you understood this concept. Now we will continue in next class. Please like, share and comment, and don't forget subscribe our channel. Press bell icon to get latest updates of classes.